In the topic of mean, we'll also learn about variance and standard deviation. But before that, before we dive into the mean, what the mean is, we'll first see what are the two types of data. So data can either be ungrouped or grouped. Ungrouped data might be like this, like there is 1, 1, 2, 3, 3, 4, 5, 5, 5, 6, 6, 7, like this, it's ungrouped, right? Now if I had this grouped, I would have a table. For example, these are values of x and there is frequency, right? So there are 1, the value of x can be 1, it can be 2, it can be 3, 4, 5, 6 or 7, right? For 1 the frequency is 2, for 2 the frequency is 1, for 3 the frequency is 2, for 4 the frequency is 1, for 5 the frequency is 3, for 6 it's 2, and 7 it's 1. So this is ungrouped data and this is grouped data. Next is the mean. So what is mean? Mean is basically the average of the data, right? Now how do we find the mean? There are two formulas. The first formula is for grouped data, is for ungrouped data. So for ungrouped data, the formula is mean is represented by x bar or x bar, so or mu, right? So for mean, the formula in case of ungrouped data is sigma x, that means the sum of all of these values, upon n, that is the total number of the values, right? Then for grouped data, x bar or mu, that is the mean, is equals to sigma fx upon sigma f. What sigma fx means is that basically if I make another row for fx, so we'll have 1 times 2 is 2, 2 times 1 is 2, 3 times 2 is 6, 4 times 1 is 4, 5 times 3 is 15, 6 times 2 is 12, and 7 times 1 is 7. This is for fx. So you add all of them up, that's the numerator. Sigma represents addition or sum, and then for sigma f you add up all the frequencies and you get the denominator. So I'll find the mean of these two datas through both of the formulas and we'll see that they'll be the same. So using this, first I'll have to add the numerators. So 1 plus 1 plus 2 plus 3 plus 3 plus 4 plus 5 3 times plus 6 twice and then 7. So I'm getting 48 upon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, right? So this is equal to 4. Then over here, we'll add fx. So 2 plus 2, 2 plus 2 plus 6 plus 4 plus 15 plus 12 plus 7 gives us 48. And then add the frequencies. So 2 plus 1 plus 2 plus 1 plus 3 plus 2 plus 1. This gives 12 again. So again, the mean is 4, right? So grouped data makes it easier to find the mean because less calculations are required. For ungrouped data, you can use this formula. Now there are two disadvantages of mean. So basically the advantage of mean is that it involves all of the values, all of the data, right? Because all of them are added and then divided by the total number. So that is one advantage, that it includes all the values, right? But the disadvantage because of this can be that if there is an extreme value in the data, that is called an outlier. So outlier is an extreme value, write it here. So if there is an outlier, then the mean gets distorted because it involves all of the values. Then the second disadvantage is that sometimes basically if the data is consistent, or if the data is inconsistent. In some cases you'll get the same mean, which is why it's not reliable. For example, if we had two datas 1 comma 3 comma 5 comma 7 comma 9, and then there's another data 5 comma 5 comma 5 comma 5 comma 5, right? I'll find the mean of the two. So for the first one, we'll add first all of them. This is using the ungrouped data formula, and then divide by the total number, so we're getting 5. The second one, we'll add all of them, so it's 5 plus 5 plus 5 plus 5 plus 5, divided by 5 again, because 5 total terms, so again the mean is 5. So these are two different datas. Over here there's a lot of variation, but over here there's total consistency, but the mean is coming same, so it can be unreliable because of this reason. Now, what is standard deviation? So as we did, the second disadvantage of the mean was that it can sometimes be unreliable depending on the data. So to make it more reliable, with the mean the standard deviation is stated. The standard deviation represents the average spread of the data, right? Now if the data is highly consistent, like we had the 5 5 5 5, then standard deviation will be 0. For non-consistent data, what we do is we use the formula for standard deviation to find the standard deviation, and basically we can't find the standard deviation directly. First we have to find the variance, and the root of the variance is the standard deviation. So for the variance, the formula that we have, variance of x, if the data is x, the variance of x will be equal to sigma x minus x bar whole square upon n. This is the formula for variance. And then standard deviation is the root of the variance. Right? Now this formula for variance can be simplified, and the simplified version of this is sigma x square upon n minus sigma x bar squared, and then the root of that will again be the standard deviation. Now one more thing, x bar is the mean, right? So we can replace x bar with sigma x upon n. Now the derivation of these formulas is not required, and neither is there the conversion of this into this, and this formula for standard deviation is also given in the MF19. Now this formula, these four formulas were for ungrouped data. For grouped data, there will be a slight change, that is that standard deviation will be equals to the root of sigma f x square upon n minus sigma fx upon sigma f whole square. So it's the same thing, just replacing x square by fx square and then the mean by the group data mean. So this is for ungrouped and this is for grouped, and then if you square this you'll get the formula for variance, and all of these three are given in MF19. Now the last thing in mean is the coded data, also called by some assumed mean, or sometimes it's called transformation of the data. So basically what happens here is that a certain value is added or subtracted from all of the terms to make it more simpler. For example, if we have a data right? Now to make this simpler, what I can do is that I'll subtract. So basically I'll say that these were the values of x. I'll subtract 600 from all of them, and I'll say that these are the values of x minus 600. So that will be 3, 7, 12, 17, 23. This makes representation of data simpler, right? So the sum of these would be sigma x. The sum of these will be sigma x minus 600, right? Now if we had to make a relationship of sigma x and sigma x minus 600, so basically what we did was that we subtracted 600 from all of the terms, right? So there were 1, 2, 3, 4, 5. We subtracted 605 times. So to go from here to there, we'll add 605 times to sigma x minus 600. So plus 600 times 5. This was for this specific data set. Now if I make this more general, so it will be sigma x equals sigma x plus a. Let's write it like this, plus minus a. Then it will be minus plus, this is a times n. Here n is the total number of terms, right? So if we have x plus a, then we'll have to minus the value of a n times, and if we have x minus a, then we have to plus the value of a n times. Now one more thing to note is that basically standard deviation is the spread of the data, right? So even if, so in both of these datas, the spread of the data remains same. The data values change, but the spread of the data changes, right? So mean will change, but the standard deviation stays same, right? So basically what happens is that standard deviation of data, if it's x, is equals to the standard deviation if the data is x plus minus a, right? But the mean will change. So mean of x will be equal to mean of x plus minus a minus plus a. So I'll explain. This is simple. I'll explain this more. So for example, if we have this data set, right, and we have to find the mean of this from this data set. We weren't given this data. We have to find the mean of the coded data, right? So what we would do is we'd find the mean of this, and then we'll add 600 to that. So basically the formula becomes that mean is equals to sigma. Basically the formula for mean normally was sigma x upon n, right? Now it will become, if it's sigma x plus minus a upon n minus plus a, right? So if we had subtracted a from all the data, from all the values, then we'll add a again in the mean. If we had added a initially, then we'll subtract a from the mean to get the actual mean. So I'm going once again through all the formulas that we'll be using. This is the first formula. Then this is for group data. These are the formulas for mean. Then there is variance and standard deviation, right? Standard deviation for ungrouped, standard deviation for grouped. And lastly, there is the formula for sigma x for coded data. And then there's the formula for mean for the coded data, right? Whereas we know that standard deviation for coded data or uncoded data is the same because it's the average spread of the data. So we'll do question one more thing. Here in the MF19 we have these formula for standard deviation and means, right? Now question one. So in question one, the ages x years of 18 people attending an evening class are summarized by the following totals. Sigma x equals 745 and sigma x square equals 33951. This is given. There are total of 18 people, right? So first, in the first part, we have to find the mean and the standard deviation. So for mean, the formula is over here. This is grouped data or ungrouped data. We don't need to know that over here. We'll just use the formula sigma x upon n, right? Because the data is given in terms of sigma x and sigma x square. So it's pretty simplified over here. So sigma x, it's given as 745, and n we know is 18. So 745 divided by 18 is equals to 41.423 SF. Then for the standard deviation, the formula is root of sigma x square upon n minus the square of the mean, right? So sigma x square was given as 33951, n is 18, mean we found as 41.4, square of that, right? So root 3951 upon 18, so it's coming 13.223 SF. And the second part, they're saying that one person leaves the group and the mean age of the remaining 17 people is exactly 41 years. Find the age of the person who left and the standard deviation of the ages of the remaining 17 people. So now I'll first find the total age of these 17 people, right? So over here, the new mean is 41. Formula for mean is sigma x upon n, that is equal to 41. N now is 17, so I'll replace it with 17. So sigma x is equals to 41 times 17, that is 697, right? Now they're saying find the mass of the person who left. So initially the total mass was 745, then a person left and the mass became 697. So the difference of these two masses will give the mass of the person who left, that is 48. So I guess it's kg, sorry, it's age, the age, sorry, right? So the age of the total people before and then the total age of the people after, the difference of that gives the age of the person who left. Now after that, they're saying find the standard deviation of the ages of the remaining 17 people. So for standard deviation, what we need is, we basically need sigma x square, we have n as 17, and then we know the mean, that is 41. So how do we find sigma x square? So basically this sigma x square and this sigma x square, what was happening was that the ages of every person was squared and then added. So if we square the age of the person who left and then subtract from this, we'll get the new sigma x square, right? So for the new sigma x square, we'll have 33951 minus the square of this person's age, 48 square. This is coming equal to 31647. So we'll replace sigma x square by 31647. So root 31647 upon 17 minus 41 square, 13.423 SF. Now question 11. So over here, Delip measures the speeds x kilometers per hour of 70 cars on a road where the speed limit is 60 km per hour. His results are summarized by sigma x minus 60 equals 245. Calculate the mean speed of these 17 cars. So we did this formula to find the mean from group data. So the formula was for part 1, right? So sigma x minus 60 is given as 245. Total cars are 70 plus 60. So 245 upon 70 plus 60. This equals to 63.5. That is the first part. Then his friend Sachin used values of x minus 50 to calculate the mean. Find sigma x minus 50. Again we'll use the same formula. So mean is equals to sigma, but we'll have 50 in place of 60, right? So sigma x minus 50 upon n, that is 70 over here, plus 50, right? But over here we have to find this is our unknown, and this is, we already know this, which is 63.5. So 63.5 equals sigma x minus 50 upon 70 plus 50. So we'll have 63.5 minus 50, right? This will go over there, and then we'll multiply that with 70 to get sigma x minus 50, that is 945. So sigma x minus 50 equals 945. Now in the third part, the standard deviation of the speeds is, so basically standard deviation is given as 10.6 kilometers per hour. Calculate sigma x minus 50 whole square. So standard deviation of sigma x of coded data and uncoded data is the same, right? So that's why you can use the formula for standard deviation even in coded data, that is sigma x minus 50 whole square upon n minus sigma x minus 50 upon n whole square. So we know the standard deviation over here, 10.6. I'll square it to remove the root, right? Then we'll have sigma x minus 50 whole square upon 70 as n. This is basically the mean, right? The mean with x minus, in fact we don't know that. So we know sigma x minus 50. So sigma x minus 50 you found in the last part was 945 upon 70, right, whole square. So we have 10.6 square. Then this shifted towards that side will become plus 945 upon 70 squared. So sigma x minus 50 square upon 70 is equal to 29461 upon 100 times 70 will give us the answer, that is 20622. So sigma x minus 50 squared, if we round it off to 3SF, will be 20600. I hope it makes sense. Next is question 13. So Red Street Garage has 9 used cars for sale. Fairville Garage has 15 used cars for sale. The mean age of the cars in Red Street Garage is 3.6 and the standard deviation is 1.925. And then it's given for Fairville Garage like this. Okay. So I'll first make 2 columns. So there is Red Street Garage, right? And then there is Fairville Garage. For Red Street Garage, n equals 9, right? The mean age of the cars is 3.6 and the standard deviation is 1.925. Then for Fairville Garage, they've given n as 15, sigma x as 64, and then sigma x square as 352. Then they're saying find the mean age of all 24 cars, right? So the formula for mean is sigma x upon n. That means we have to add the ages of all the cars divided by the total value of total number of cars, right? So the total number of cars will be 9 plus 15, that is 24. The challenging part is finding sigma x, so it's 2 marks, right? Now first, using this, I'll find total age of cars in Red Street Garage. So basically I need to find sigma x of Red Street Garage. Sigma x upon n upon 9 will be equal to the mean, that is 3.6. This is the formula for mean. So we get sigma x as 3.6 times 9. That is 32.4. And sigma x of Fairville Garage is given. So the total sigma x will be 32.4 plus 64, and then divide that by 24 to get the mean. So 32.4 plus 64 upon 24. 4.02 to 3SF. Now in the second part, they're saying find the standard deviation of the ages of all 24 cars. So for the standard deviation, we'll need sigma x squared of, let's write it like this. So sigma x of Red Street Garage is sigma xr, right? And then plus sigma x of Fairwheel Garage squared upon the total n, that is 9 plus 15, that is 24, right? Minus the total mean that we found in the last part, that was 4.02. So minus 4.02 squared. So now what we have to find is these two values, the standard deviation, the sigma x squares of Red Street Garage and sigma x square of Fairwheel Garage. Right, so sigma x square of Fairwheel Garage is given, that is 352. So this is basically sigma x f square as we've written in the next part. Sigma x r square we have to find, right? So how will we find that? Over here we have the standard deviation. We know that the standard deviation is equals to the root of sigma x. Now over here that will be sigma x r square upon n is 9 in this case because we're only taking Red Street Garage right now, minus the mean, that is 3.6 squared. So I'll take the square over there. Standard deviation is 1.925 and then square it to remove the root from there, equals to sigma x r square upon 9 minus 3.6 square. So we have 1.925 squared plus 3.6 square, right? We'll multiply this by 9. So sigma x r square is equals to 150. So for Red Street Garage it's 150, for Fairwheel Garage it's 352. So it's 150 and 352, sorry. So this is equal to 150 plus 352, again, yep, upon 24 minus 4.02 squared. So this gives us 2.18 to 3SF. This is the standard deviation of all the 24 cars. Next is question 19. So a summary of 30 values of x gave the following information, where c, so basically n is 30, c is a constant. So over here we have coded data with c subtracted from all the values of x. Find the standard deviation of these values of x. So standard deviation remains same for coded or uncoded data. So if I find the standard deviation for the coded data, that will be the same as the standard deviation for the uncoded data, right? So standard deviation will be equals to the root of sigma x minus c squared upon n minus sigma x minus c upon n squared. So it's basically equal to 1957.5 upon 30 minus 234 upon 30 squared. So root 1957.5 upon 30 minus 234 upon 30 squared. This is coming equal to 2.1. That's the first part. Then in the second part they're saying given that the mean of these values is 86, right? So the mean of the values of x is 86, find the value of c. So the mean of the uncoded data is 86, we have to find the value of c. Now in the second part, so what we'll be using the formula for mean, that is sigma for coded data, sigma x minus c upon n plus c, right? Mean is given as 86. Sigma x minus c is given as 234. N is 30 plus c. So c is equals to 86 minus 234 upon 30. That is 78.2. Now question 22. So Barry weighs 20 oranges and 25 lemons. So again there are two different sets over here of data: oranges and lemons. Oranges are 20, lemons are 25. Then they're saying for the oranges, the mean weight is 220 grams and the standard deviation is 32 grams. Whereas for the lemons, the mean weight is 118 grams and the standard deviation is 12 grams. Find the mean weight of the 45 fruits, the total mean weight of both the oranges and the lemons. So again, the formula for mean is sigma x upon n. N we know is 45 for the total. Sigma x, for sigma x what we'll do is we'll have to have sigma, if we represent the oranges as xo, so sigma xo, we'll have sigma xo plus sigma xl for lemons, right? To find sigma xo, what we can do is we'll multiply n with mean, that will give us sigma x. So 20 times 220 equals 440. For sigma xl, it will be 118 times 25, that is 2950. So it will be 440 plus 2950 upon 45. This is coming equal to 75.33. Sorry, it won't be 440, it will be 4400. Yep. So 4400 plus 2950 divided by 45. Sorry, 163 will be the mean. Now in the second part, they are saying the individual weights of the oranges in grams are denoted by XO as we did ourselves, and XL for lemons, by first finding sigma XO square and sigma XL square. So first we'll find sigma XO square and sigma XL square, right? So for sigma XO square, the standard deviation, we'll use the standard deviation formula. 32 equals root of sigma XO square upon n minus the mean squared. From this we'll get sigma xo squared, that is 32 squared plus 220 squared times 20. So 988,480. For lemons, we'll have standard deviation 12 equals to root of sigma xl square upon 25 minus 118 squared, right? So to find sigma xl square, 12 square plus 118 square times 25. So sigma xl squared is 351,700. Then they're saying find the variance of the weight of the 45 fruits. So the formula for variance is sigma x squared upon n minus the mean squared, right? So sigma x squared will be sigma xo squared plus sigma xl squared upon 45 minus mean we found in the last part, 163 squared. Sigma xo we found as 988,480 plus 351,700 upon 45 minus 163 squared. So 988,480 plus 351,700 upon 45 minus 163 squared. So this is equal to 321023 SF. Now in question 29, now over here we have group data. The following table shows the results of a survey to find the average daily time in minutes that a group of school children spent in internet chat rooms. The mean is given. Form an equation involving f and hence show that the total number of children in this survey was 26. So in group data, the mean equals to sigma fx square, sigma fx upon sigma x, right? Sigma f. Sorry. This is the formula for group data. Now the mean is given as 27.5 sigma fx we'll have to find, sigma f also we'll have to find, right? So first I'll make a column of fx, right? So if we have fx, now how do we find fx over here? So basically what we used to do was that we'd multiply frequency with the value of x and get fx, but over here there is a range of values of x, right? So we'll take the midpoint of these. So first I'll make a column for x will be the midpoint of each of these. For the first one it will be 0 plus 10 upon 2, that is 5, 10 plus 20 upon 2, that is 15, 20 plus 40 upon 2, that is 30, and 40 plus 80 upon 2, that is 60. Then fx will be basically frequencies. Let's write them down to make it simpler. So 2, f, 11 and 4. So fx will be 2 5s are 10, f times 15 will be 15f, 30 times 11 will be 330, 40 times 60 will be 240. So now we've got fx. Now if we have to find sigma fx, so that would be the sum of these. I'll add the first and the last two. 10 plus 330 plus 240, 364, sorry, 10 plus 30 plus 240, 580 plus 15f. And for sigma f, this is the sum of all of these. So 2 plus 11 plus 4 is 17 plus f. So sigma fx we know is now 580 plus 15f upon sigma f is 17 plus f. So 27.5 times 17 is 467.5 plus 27.5f equals to 580 plus 15f. 15f taken to that side, that will be 12.5f equals to 112.5. So f equals 9. Now f is 9. What they were saying is show that the total number of children in the survey was 26. You have to show the total number of children, that is the total frequency. So that will be sigma, basically have to find sigma f, that is 17 plus 9. This is coming equal to 26 as we have to show. Next they're saying show this, find the standard deviation of these times. So for grouped data, the formula for standard deviation, which is also given in the MF19, is root of sigma f x square upon n minus the mean squared. We have the mean, yep. So this will be equal to, so basically we have n, we have the mean, we have to find sigma fx squared, right? So sigma f, I'll have to make a column for sigma for fx squared now. So fx squared means that f is multiplied by the square of x. So for the first one, 2 times 5 square, that is 50. F we know is 9, so 9 times 15 squared, this is 2025. Then 11 times 30 squared, this is 9900. Then 4 times 60 squared, this is 14400. So sigma fx square minus this, sigma fx square we'll have to find, we'll have to add up all of these. 50 plus 2025 plus 9900 plus 14400. So 26375 upon the total number, that is 26, minus the mean squared. Mean is given as 27.5. So root answer upon 26 minus 27.5 squared. This coming equal to 16.1.